Are doing well cosines. Yesterday, well, sines, that was pretty easy. I hope you found that pretty easy.
So we need to get those out now?
Yeah, we're doing notes right now.
Well, you just get a whiteboard.
Yeah, because I want to get ready. Alright, so law of cosines. There are technically like 3 formulas of law of cosines, but if you can see the pattern, you only need to remember one. So I'm going to try to show you with the pattern. Alright, so let's say I have a situation like this. It's not a right triangle. And let's say I have, this is side A, side B, side C. So that means this is little a, little b, little c. Alright, the way the law of cosines works is that I have, I'm concerned with sides that are across from certain angles. So if I'm concerned with this, okay, like either I want to know angle A or I want to know side A. In either of these cases, it's this. A squared equals B squared. See these two sides plus C squared minus 2BC cosine A. Notice that I have side A here, and at the end, the cosine of its opposite angle. Okay? And then the other two sides make up the rest. You with me? I'm going to rewrite that again. I just want a copy of this triangle so that I can paste it really quick. So I'm going to try to get it. Hold on. Try to get the copy.
Did you figure out why it was so wonky yesterday?
Yeah, I don't know why it was wonky. Okay, anyways. Wonky. So if we are either looking for angle A or side A, okay? Notice they're across from each other. It's A squared equals B squared plus C squared. I add the squares, minus 2BC cosine of angle A. And notice the side is opposite the angle. Okay? So you can basically use that for all of them, but let's just say we wanted to construct the other formulas. So we'll use the same triangle, but let's say this time I'm interested in B. So in this case, it's going to be B squared equals, now I have, you see how I have these other two sides? A squared plus B squared minus 2AB. Why did you let me do that? No, that's wrong.
C squared?
It's C squared.
I was about to ask you that.
Yeah, it's A squared plus C squared minus 2AC cosine of B. And
so
again,
it's minus 2 of whatever two sides you don't use?
yes. The sides that you don't use appear right here. Or, well, you don't use the other two sides. The two sides, you would have to know what A and C are. And you have to know what B and C are. And then either one of these other, you don't. Alright, one more. Okay, so let's say I wanted C. Now, in order for this to work, I need to know these two sides that I'm underlining in each of these cases. I would need to know those two. And then of the remaining two things, either the angle or the side, I would need to know one of them. Alright, so in this case, that would be C squared equals A squared plus B squared minus 2AB cosine C. And that gives me these. Notice side angle. Okay, so let's get our calculators ready and make sure that you are in degree mode. And let's do a few examples. Okay. First example. Let's say this is 6.2. Let's say this is 7.8. Let's say this is 45 degrees. And we'll say we want side X right there. So I'm just going to delete these, because really those don't matter. So notice, and here's what you need to see. I have two sides that are consecutive. So they're consecutive, and I know them. And I know this angle. And I'm looking for the side opposite. So that's going to be x squared, see this is the side I'm concerned with, equals 6.2 squared plus 7.8 squared minus 2 times 6.2, 7.8 cosine of 45. Now we're just going to whittle this down, but we want to be careful because often, very often, students mess up this piece right here by not doing the order of operations correctly. It's a -2, but I might get, like if this angle were larger, let's say it was 120, then this will change to a positive, which we'll actually do an example of that shortly. So we have x squared equals, we have 6.2 squared, so that's 38.44 plus 7.8 squared, 60.84, minus, I'm going to go ahead and do all of this at once, but I won't, I've got to be careful about this negative. In fact, maybe I wouldn't, oops, I didn't want to move the slide. Maybe I wouldn't even write it until I do this. So we're going to do -2 times 6.2 times 7.8 cosine 45. And then my calculator spits out -68.39. Now, whatever sign, if I do it like this and I type all of this in, including that negative, into my calculator all at once, then I just take whatever sign my calculator spits out. Okay? Sometimes it'll spit out a negative, sometimes it'll spit out a positive. Whatever it spits out, that's what we want. So we have x squared, we'll just add all those. I get 30.89. And then we'll square root it. Okay, this is approximation. We got to be careful with that. This is approximately. We didn't do it exact, right? So that's how many units x would be.
5.52.
Mm-hmm.
That's easy.
Okay.
We just gotta read before we go. What the world is going?
Okay, that's an obtuse triangle. All right, so how do I know when to use the law of cosines? When I have an angle included or sandwiched between two consecutive sides. That's when I'm going to use law of cosines. And also if it's not a right triangle. Okay, law of sines, law of cosines apply for triangles that are not right.
Is there a law of tangent?
No.
Good.
No law of tangents. All right, so we're interested in this, right? So this, it might even help you to do this. So it is x squared equals 9 squared plus 3 squared. See where I got those? Minus 2 times 9 times 3 cosine of 100. 81 plus 9 minus 54 cosine of 100. I did that in steps. I don't know why I did it like that, but did I do that right? I guess so. Okay, so negative 54 cosine of 100. Now my calculator spits out a positive, not a negative. So I can do this addition. I follow my order of operations. 90 plus 9.377. So x squared equals 99.377. And then I square root that. So x is approximately 9.97.
Yay. So much stupid.
Okay, sometimes we're looking for the angle. So I don't know how this will come out. Okay, so
6 squared equals
yep, 6 squared equals 7 squared minus
2.
now I'm looking for the angle, so that tells me I'm going to need it to use an inverse. So 6 squared is 36, 49 plus 64 minus 14 times 8. So minus 112 cosine x. Now, look very carefully, all eyes up here. Here's what some students do. They start adding and subtracting all these numbers up here, because we get used to it up here. But that's wrong, because this is not like those, is it? I cannot do 64 minus 112 because I have this cosine here, which makes it not like. So I do 36 equals, I have the 49 plus the 64. I get 113 minus 112. Boy, is it so tempting to do 113 minus 112. But I cannot do it because these are not like.
Have to subtract it.
So I subtract the 113. It is okay to get a negative right here.
Negative 77.
So I have negative 77 and then negative 112 cosine x. Divide by negative 112. So 77 divided by 112. I get 0.6875 equals cosine x. That's nice. Now we inverse cosine. And we get approximately 46.5657. So 46.57 approximately degrees, because we're in degree.
Boom.
Okay.
So when do we get all that hard crap right here?
Next, that's the next thing.
Does that after spring break?
Yeah, that's going to be after spring break.
So
Okay,
we're going tomorrow.
hold on. The final thing, well, for today anyways, is finding area of a triangle. What's the formula for area of a triangle?
That was a long time ago.
1/2 something.
No, boy.
Yeah, it's been a long
My
time.
juniors don't know area formulas.
It's been a while.
Base times height.
Two.
Thank you. Grant with the win.
I know it was
That
like a
is-
half
He
something.
took geometry last year.
Okay, so anyways, this is the area of a triangle. So since we apparently don't know anything, let's say I have this situation. And this is very easy. The height must be perpendicular to the base. Okay? So if I want the area of that, I'm going to do 6 times 10 divided by 2. 60 divided by 2 is 30 units squared. That's the area of that triangle. Now, it couldn't possibly be that easy, right? Because this is Algebra 2, your juniors. This is like a 4th grader problem. So no, not that easy. That's not the situation we're going to have. But we do want it to get to be that situation. So let's say we start with our triangle. Hopefully you really don't need notes on that area. Let's say I have 40 degrees, yeah, that was just a reminder. I have 40 degrees here. And let's say I have this side. Let's say this is 6. And let's say this is 10. Now, I am missing what?
The other side.
The other side
Yeah.
before this side.
Well, yeah, I'm missing this side, but I'm finding area. And in order to find area of a triangle, what's the area formula for a triangle?
Base times height over 2.
Base times height divided by 2. I am missing, Grant, the height. I'm missing my height. But where is it? It's not even drawn, so I need to draw it. So in this case, whenever we have an angle, we have two sides, similar to this situation, I need to draw my height, and I always want to draw it across from this angle. There's my height. Now, what type of triangle?
Right.
It's a right triangle. This right here, do you see it? Is a right triangle. Okay, so let's take this right triangle over here. Now we know this is a 40-degree angle. We know this is 6.
You have the hypotenuse.
I have the hypotenuse, and this is the height of my triangle. Now, do I know this side right here?
Is it 5?
5.
Or is that too easy?
Okay, let's draw this triangle and see. Let's say this is 10. Let's say for some reason that's 40. This is 6. Okay, draw that down. Let's
No.
exaggerate it. Okay. Is that bottom 5?
No.
No. I have no way of knowing what this is. I can't use it, not helpful. And luckily, I don't even need it. Because this is a right triangle, my regular trig functions work. Sine of an angle, cosine of an angle,
Use sine.
tangent of an angle.
Use sine.
And I use sine. Opposite and
How about the...
so sine of 40 equals h
H over
over
6.
6, which means h
Multiplied by 6.
is 6 sine 40, which is about how much?
3.86.
3.9.
Okay. So 3.86. So that's my height. So now I'm ready to go to my area. Area of the triangle is my base, which is 10. My height, it's not going to be 6, is that 3.86 that we just calculated, divided by 2. So we get 19.3.
Yeah.
Now, you can do what we just did right here, separate the triangle, find the height separately, then come back in. And that's fine, but it'll be confusing if you have a situation like this, where the triangle is not acute. If I have an obtuse triangle, and say this is 100 degrees, and let's say this is 3, and say this is 7, well now where's my height? I can't draw, I mean I can draw my height across from this, it would be over here.
Once you draw where?
Okay, and I would actually draw it here, but then my right triangle's over here. It's not as obvious what to do. You can still do it, but it's not as obvious.
There.
Luckily, it does not matter where that height is. In the end, my height will always end up being 7 times 3, or my, sorry, what am I doing? 7 times the sine of my angle. Okay? Or whatever this slanted side here is. Whatever the side that is not the base. So I'll draw where the height is. See, it is over here, just so I can identify my height. My height is 3. But in the end, the area of a triangle, which is base times height, divided by 2, is going to, if I have a case like this, is always going to end up being a side, whatever side I want, say A1, times my other side, say A2, times the sine of my angle that is between them, whatever, theta, divided by 2. This will always give me the area of a triangle when the setup's like this, and I don't need to worry about anything. I can just use this formula instead of going through all this mess. Now, it's not that big a mess, though. Did you understand it?
Yeah.
Yeah. But, I mean, let's do another situation. You know, I'll just throw a triangle up here, 12, 25 degrees, 20. Okay? So, let's go ahead and figure out the area. The area of this triangle is 12 times 20 times sine 25 divided by 2. And I don't have to worry about drawing this height in. We just did that so that you can see where it was coming from. Okay, so we go ahead and put that in our calculator. Make sure that you're in degree mode, of course. And we see that the area of this triangle is approximately 50.71 units squared. Okay?
Gonna go down a lot more.
Yes.
Wait, hold on.